Hey everybody, this is Larry. This is the third day of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button. I'm going to do this every day of the month, so join me in subscribing or the Discord channel talk. I'm a little bit awkward doing this part, but that's okay. Yeah, let's go over today's problem, which is prison cells after N days. So first thing to notice is that you could do a simulation, like the rules are here, you could do it and that'll be fine, and then they throw you into a loop, which is that n could be 1,000,000,000, and the question is, how do you think about this, right? Well, the thing to always make sure, especially if you're on an interview or a programming contest or whatever, is that always check your constraints, right? And well, the first thing you notice is that n is equal to 1,000,000,000. So you're like, okay, well, if I simulate that, would that be fast enough? Well, 1,000,000,000. My roughly back of the hand calculation is that, well, if you let's just say you have a for loop and you update the array, which has 8 elements, so that does roughly 8,000,000,000 operations. And on the order of it probably does even a little bit more than that, but that's an 8,000,000,000 operations, which is way too slow for simulation. You could do some math on how fast your computer runs and stuff, but yeah, it's gonna be way too slow, right? So then the next thing you notice is, okay, cells.length is 8, so can we take advantage of that? Well, another pairing that goes with the k is equal to 8 is that each cell sub I could only be 0 and 1. And I mean, this makes obvious sense because when you read it, I mean, it can only be 0 and 1, right? So then you think, well, how many possibilities are there for an array? Well, because they're binary and each are 8, then it's just going to be 2 to the 8th, right? Which is 256. And from that, you think, well, if there's 256, what does that mean? And from this point, there's one more observation that you have to make, which is that for any given input, the next output will be determined. It will always be the same, right? There's no randomness. There's no rolling dice. There's no nothing. The rules are very defined. It is the same every time, and because the rules are the same every time, anytime you give the same input, you always get the same output, no matter what. So from that's something that you could build on. And what does that mean, right? That means that, in a way, there are a couple of ways you could play around with it. Maybe you could think of it as just dynamic programming or something like that, but I think of it as just more visualization-y. Let me pull up Paint real quick. So basically, for example, if you look at each state and the 2 to the 8th of them, which is, so let's say you start here, and then you run a simulation. Yoink. Need a better tool for this, maybe. But yeah, you send a simulation, and then it takes you to here, right? And then that's pretty much, let's do that a few times. Let me do some magic copy and pasting. Okay, close enough. So you do that a few times, right? And then because there are only 2 to the 8th of these, which is 256 of these, at some point you're going to run into a cycle, right? So say you have something like this, and then the next one, actually, when you simulate this, it actually points to, oh, that this would be a line. Okay, maybe this one better. The next one goes back to here, right? Well, that's pretty much all the insight you need for this problem, is that, well, you simulate it, and at most it's going to go around in about 256 times, or maybe double that if you do it some fancy way, or non-fancy way maybe. Then at that point, you're able to figure out the length of the cycle by counting it, by keeping track of it. And the way that we keep track of it is, well, the way that I kept track of it anyway, is you label the top one, times 0, which is your starting point, your second one here, or 2 there, 3 there, 4 there, and then 4 goes back to 1, right? So that means that, what does that mean? That means that the cycle length in this case is 3. And for something like 1,000,000,000, then all you have to do is figure out this and then do some math, which is, now that you draw it out, and I always advocate keeping a notebook or something like that when you do something like this, or if you're on an interview, obviously you just do it on a whiteboard, so that you can actually draw this out and then talk yourself through this, because the visualization really helps a lot. And with enough like maybe you've watched videos and people are just like doing it on their behind. That's mostly because they've done similar problems, so they're able to visualize this and then just do the math directly. But if you're if you're starting out, you're just coming out and working on this, then there's no shame in just drawing it and figuring out. So in this case, the loop is 3, right? So what does that mean? That means that, let's say your number is 1 billion. Well, you take off the top, the stuff that's before the loop. So you subtract, in this case, you subtract 1, and then your loop is 3. That means that every third one will repeat. So then you just mod the remaining by 3, right? Something like that. So you could do the math that way. I know I'm hand waving a little bit about the math, but it is something that you can do yourself. But now that you draw it out and you have these numbers, you could play around with it to manipulate it. I know that I'm giving you an explanation, but I also want you to just practice it, because just even though it is straightforward, just doing it yourself will give you that like intuition and learning that you might actually use next time. And next time you won't have to figure out the math. You'll be like, oh yeah, no, I did this, and then like this math is kind of like this, right? And playing with mods and stuff is something that it doesn't come intuitive until you've done it enough times. So yeah, so let's go over my solution real quick. So I did basically what I said. The implementation sometimes is a little bit tricky, and in this case I did take my time a little bit, but basically I keep a dictionary of when I last seen something. I keep a track of the current time, and then every loop I just increment the loop. I just create a next cells array so that I keep track, and then for every next cell, this is just the rule set that's in the in the problem statement. So this is should be pretty straightforward from simulation. And what I did is just add this thing where there are 2 logic, right, or 2 parts to this logic. One is, I convert it to a binary number, so it's a little bit easier to hash, like in a hash table, and because we know that it only goes up to 256, that's okay. We just use a very simple binary algorithm, or hash an array to a binary number, which is base 2 number, and you could play around with that. If we haven't seen this number before, we just said, last seen is now, right? And we had seen it before, then we go, okay, the cycle length is just the current time minus the last time we saw it. And then we just do this math, which again, I urge you to prove. I had a little miss situation where I did not do this, but obviously I did it and I fixed it. You could watch the live portion right afterwards. With this math, you could figure it out. And I do want you to figure it out, because this is, something that will help you a bit. And also, I forgot to get rid of this thing. But yeah, so this is the... sorry about that. I hope this is still understandable and readable. You could have watched most of it, so I think maybe that's okay. If not, let me know in the comments. That's pretty much it. So yeah, so this is the formula that... But there are other ways to think about this problem, and there are other ways to come up with similar but not the same formulas. So yeah, so play around with this problem, and yeah, let me know what you think. Leave your comments in the comments section, because where else would you leave it? I guess you could join the Discord, but also stay and watch the live portion right about now. Hey everybody, this is the live portion of the Leetcode July Daily Challenge. Let's get started. Prison cells after n days. There are 8 prison cells in a row, and each cell is either occupied or vacant. Each day, whether the cell is occupied or vacant changes according to the following rules. If a cell has 2 adjacent neighbors that are both occupied or both vacant, then the cell becomes occupied. Otherwise, it becomes vacant. Okay, they're both occupied. Okay. Note that because the prison is a row, the first and the last cell can have 2 adjacent neighbors. We describe the current state of the prison in the following way. Cell survives equal to 1 if it's occupied, okay? Given the initial state of the prison, return the state of the prison after n days. and then it's 10 to the 9th, so that means that we have to be a little bit smarter. My first instinct would have been to use just straight up simulation, given that this is 8, but given that a billion, we have to do something smarter. So the thing to notice is that because cell length is 8, 2 to the 8th is 256. And what that means is that given a certain input, you know that what the next input is going to be exact, because, or rather, given a certain input, the next input is going to be deterministic, because for the same input you get the next input, right? So because of that, that means that at some point it would form a cycle, and then from that cycle we could figure out what we have to figure out how the thing goes. So yeah, let's kind of get right to it. I know that I'm not using words quite right now, but well, the explanation portion, which is actually before this portion, I suppose, I'll have more visualizations, and then you could see how that works out. But that's how I'm going to think about it. So yeah, so let's start by doing the simulation first. And so maybe I'll have a sort of a. Alright, so we'll do it without the loop thing first, and then we'll just add that in. Okay, so was it times n? Okay, let's just do time is 0, 0, and then while time is less than n, time increment by 1. I'm writing this. This may look a little weird because normally you would just write a for loop, but it'll make a little bit more sense once I do it. And some of this is having practice with some of these, even though mainly for this particular type of problem, I think it's been a long time ago. So, but I know that I need to manipulate time so that it doesn't always increment by 1. But yeah, so then we have let's just do next cells is equal to what's it? O times 8. It's always 8, right? Yep. Okay. And then now for each cell, okay. So for so the one thing I just noticed is that actually is even better because other than the first state, first day, the input, the first and the last cell is 0. So in theory, you could actually even take advantage of that to make it just 64 possible states. But we'll see how I feel about that because it's not even. I have a sense that it's not even necessary, but it's something to keep in mind. So let's just go from, let's call it index to be more clear. Let's make it from 1 to 7, inclusive. So I know that 7 plus 1 is 8, but I write it this way so that it's a little bit more clear, hopefully. So next, okay, fine. If cells of index minus 1 is equal to cells of index plus 1, then next cells of index is equal to 1. Else, next, I was going to write this in one-liner, but I don't know, I just didn't want to. Or like I didn't want to make it. I want to make it slightly more easy to read, rather, not more confusing. But yeah, and then now at the very end we do cells is equal to next cells. And then in theory, that should be good. Do we return the cells? Okay. Yeah. Oops. So in theory, this should work. Let's just test this real quick. It should work for the n is equal to 7 with no problem. Oopsie. I messed it up. So it should go for 8. It should go up to 7. Oh, 0 to 7. Okay. So this is actually. Okay, so it's 7 plus 1 minus 1 because I forgot forgot about not doing the last one. Okay. Okay, so this looks good. Clearly it's not going to run for the n is equal to 1 billion because this is way too slow. I could show it, but we both know, right? So now, and now this is why we have a time as well. It's go, let's see. Well, we could keep track of when the last thing is, last time we've seen this. So yeah, let's do that. Okay. Last seen is equal to a dictionary. And then now we have a helper method to convert this binary array into a binary number. So it's just for a little bit easier hashing. You can actually probably do it without, but I would probably do it. So at the beginning, if last seen of what is it? Oh, to binary. Well, let's just go binary to binary of the cells, and if last seen of binary. Oh, a little bit rusty right now, but yeah, binary is in last seen. Then we do some maths. Else last seen of binary is equal to time. Okay, what to figure out how to handle this. So if that means if we've seen it already, then we look at the current time. So then the cycle is equal to cycle length is equal to the current time minus last seen of binary. It may be a little off by 1. I always have to double check this, but yeah. And then now with the cycle length, we can advance time by that much. A little bit more mathy than that, right? So that means that, let's say we're at n minus time left, and then each cycle length. So we want to keep getting the divider. So we take this, and then whatever's left is n. We set the time is equal to n minus all this stuff. Yep. And I'll explain this, or maybe I already did. Something like that. Okay. Well, that's reassuring, but it doesn't test anything because there's no cycles, I think. Maybe I'm wrong on that one, actually. But let's try this case. Let's just try a case where we didn't know the answer. Oh, I didn't know the answer anyway. Yeah, okay, wow. Okay. I was thinking, to be honest, I thought that I might have to deal with a one off by one somewhere and have to debug. So I was mentally prepared for it. Like I was not actually expecting to get it on in the first try because I haven't done this in a while. Now I'm just testing some random stuff, but okay, well, okay. Let's just submit it. Oof. There is an off by one somewhere, maybe. But it's still reassuring that the answer is over there. But it may be that the cycle length is 1 or something like that. So maybe that's why my offset is a little bit weird. But also, I think the reason is because I go +1. So yeah, I have to maybe do a check first. If time is greater than well, it should be only equal to n, but break it's maybe a little bit careless on not checking that. Okay, so actually that may be the case. So let's submit again. I was going to write some print statements, but fingers crossed. Okay, cool. Wow. Okay, so only one minor thing. Yeah. Okay. So this is what happens. But okay. Whew, that was actually not as bad as I thought it would be. Mostly because I'm rusty, and some of it is me being a little bit vulnerable on stream. Is that I mean I appreciate the practice, but I'm not practiced on everything, right? And I have done this before. Not this particular problem, but these kind of problems where you have this like loop structure where you've seen something and you're trying to get back to it. So what is the complexity, right? Well, the complexity is actually just, and I said like you can actually reduce it a little bit, but it's okay. The complexity is actually just 2 to the 8. In a way, it is constant, given that 8 is the cell length. If you allow it to be a variable, if you allow it to be say x or k for some length k, then it'll be 2 to the k. And why do I say that? Well, because this loop runs at most O of k times, right? Because after 256, 2 to the k times, right, which is 256, and because this will, there are only 2 to the 8th possibilities to this binary variable. So last seen can only be O of 2 to the k, which is 256 in this case. Because after that, well, then time gets advanced a lot. And yeah. And that's pretty much it. And the space is also 256, so we only, well, okay, depending on how you want to say it, because I do reallocate new space per se, but you could actually rewrite this a little bit in a way that reuses space in a cycling kind of way, so that it is still O of 256, which is O of 1, maybe, or 2 to the k, say, maybe that's clearer. So this is still O of 2 to the k space, because you could rewrite this, but everything else is just dominated by the last scene. Yeah. And this is k times 2 to the k is the running time complexity, because this loops at most O of 2 to the k times, and each loop does O of k work. So total time complexity is O of k times 2 to the k, where the space complexity is just 2 to the k for the last scene. You might have to make some optimization again. And yeah, this is, I don't know if this comes up on an interview. I know that there are like weird, was it Freud's turtle and the hare, something like that algorithm. So it's kind of similar to that, but it's still not an algorithm that I've seen on interviews that often. I don't know how I feel about it, but yeah, it comes up here and there on competitive program, but I have not seen it on an interview. That is to say, or that is not to say that you shouldn't study it, but make sure you get your fundamentals in a correct order or correct strength first. I think this is probably like extra credit, if you ask me. But yeah, that's all I have for this problem. Yeah, that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button. Remember, I'll be here all month. So yeah, and I'll just join the Discord if you like. And I will see y'all tomorrow. Bye bye.